So, good afternoon all. My name's Tabitha Binding. I'm Head of Education Engagement for Timber Development UK. And this is the second series from TD UK, where we're creating the opportunity to learn from the multidisciplinary teams behind the incredible projects that were entered for the Wood Awards 2022. Timber Development UK has been formed from the merger of two of the largest and longest established organisations in the supply chain, the Timber Trade Federation and TRADA. Our aim is to connect the supply chain, to lead best practice and accelerate a low carbon future, to make a better world for all. And why we're here today with Tom and Polly and see, I always forget names. I'm absolutely terrible on names. And if anything's going to go wrong, this will go wrong. 9 days left to enter the Wood Awards. So get your skates on, send us in. You know, there's so many categories that you could enter, and we would be delighted to talking to you next year. So we're here today for the UK Hardwoods Storage Building, and Tom and Polly from UK Hardwoods and Robin from Buckland Timber will now take over. And I invite you to introduce yourselves and share the screen. One last thing, I always forget something as well. Any questions, please type them into the Q&A box. You know, Polly and Tom and Robin can see them. We can pick them, some of them up as we go along, or we can take them at the end. So please, this is your opportunity to learn from the professionals at the forefront of the UK timber industry. It's all yours.
So I'm Robin Nicholson. I'm from Buckland Timber, glulam manufacturers, just down the road from UK Hardwoods. So we design and manufacture glulam, and we're sort of the only one in the country, certainly any kind of specialist glulam manufacturer, kind of aiming to make stuff out of locally grown timber. And I think today because all three of us are here, it's going to be kind of a intentionally unrehearsed kind of conversational type of sort of presentation. So we'll kind of pass between the three of us as we sort of go through the process of what we've done. So I will hand over to Polly or Tom. Polly.
Oh, you go first.
So I'm Tom Bedford, who started running UK Hardwoods about 12-13 years ago, and about 6 or 7 years ago married Polly, and Polly came into the business. So we're just working together and expanding. We buy solely English timbers, sort them up, and
6 or 7 years ago.
Yeah. Hiya, I'm Polly Bedford. Yeah, married to Tom here, and yeah, we run UK Hardwoods together. So we buy English timbers, only ever English timber, predominantly from the southwest of England. The furthest north we go is sort of Bristol, Hertfordshire, that sort of line along the country there. So not that far north in many people's opinion. And yeah, we buy an English timber, saw it, dry it, kiln dry it, and come up with an end product. We do joinery, and flooring is the main sort of outlet of where our timber goes to. We deal with the end customer, so going straight into our customer's sitting room or kitchen, and we deal with architects, interior designers. Sort of no project is too big or small for us to talk about and discuss. But we started off, well, Tom's had business for 12 years now. It's been under his name, and when I joined, we started sort of getting a bit bigger, and it's got a bit, it's snowballed, yeah, a little bit, which is good, but we definitely needed more space. And so we used to have one shed with,
so try and share the screen so you can see it.
Yes, yeah. We had one shed with all our timber in it and all of our machines, and it was just a bit of a nightmare. So we got some government funding and put in the planning permission to get a steel build building. We hadn't actually thought of glulam at this point. And we got planning and it was all granted, and then some trees came up for sale, and Tom will sort of tell the story of those in a bit, really locally, and it got Tom sort of 2 a.m. waking up in the middle of the night thinking, we must be able to do something with these trees. It just seemed, it was actually Tom's brother's woodlands, and that's why it seemed so, the link was there, it just, we didn't know how to make it yet at that point. So yeah, lots of waking up at 2 a.m. and thinking there's got to be a better way of building rather than steel. So the decision wasn't solely cost, it wasn't design, it wasn't just out of our own interest in timber, it was an amalgamation of those three things. And what we've really found is this on, how do I go on to the slideshow? We've definitely found with our customers having this building, they're more interested in the building than they are coming to see the flooring. So they might come down from the Cotswolds or London to see our flooring, and the building sort of takes over, which is lovely. But yeah, this is some of the flooring we do, and just some of the projects we work on. But there was a need for a building, and so Tom went and visited, I think he Googled glulam timbers near me and paid a trip down to Robin, which wasn't far. So I'll pass on to Robin now.
Yeah. So yeah, which Tom sort of just kind of turned up one day, which is how a lot of our customers do, which is fine, it's good. And I like this kind of job because it's more or less, the brief was kind of a rectangle, 18 by 36, which is, you know, an eaves height, ridge height, and that's kind of all you need. And so these are actually the notes from our kind of initial meeting, and you know, really actually kind of straight away, you know, the kind of the sort of essence of the design is there. But
there weren't any more drawings after that.
that's the fabrication drawing there. Yeah. So, but I think I need to kind of go back and give Tom some credit. I guess my first reaction to Tom saying he wanted to make a building out of his own timber was immediately to say, you know, steel's probably cheaper, Tom. Just build a steel building. So, like, totally not kind of promoting what we're doing. And sort of the background to this is we've been kind of plugging locally grown timber for years, but sort of gradually drifted away from it just because it wasn't kind of commercially viable. There wasn't enough demand for it, and which I'll come on to later, we didn't at the time really have good suppliers. So there's lots of sort of things fell together in the same time of establishing this relationship with UK Hardwoods. But yeah, I think I feel like Tom went away from our meeting with me saying we should do it out of German. Don't, you know, these silly ideas about using your own timber. Luckily for me, Tom was kind of a bit, I think he actually rang me up and said, this makes me feel a bit sad, really, that I kind of said, okay, right, have another look at it. And we did, and then we ploughed on with the locally grown route. So I think I'll go to the next slide, which will be so you know, I guess I should do some kind of technical stuff of how the building's designed. So it's a portal frame with we call it a pitched curved beam or a boomerang beam, and these are kind of very efficient use of material, which has actually become more and more as timber prices have gone up. Efficiency and use of materials become more of a key sort of design constraint that we think about more, which is good. And so a boomerang beam or however we want to call it, it's got a lot of wood in the middle and less wood towards the outside. So where all the stresses are in the middle, it's bigger. And so you're making a good use of timber. And then I think we've got pinned eaves and then a moment connection, which is the only slight little kind of downside of this sort of design. Is you might notice that Tom definitely complained about the size of the footings, but it's cantilevering up from the ground, so it needs a fairly hefty fitting and footing, and there's some sort of a significant metalwork in the bases.
The site was sloping, so we had to have a retaining wall as well on that northern aspect of it, which I imagine that's, I think, the reason for the tie beams, the tie bars underneath the concrete slab. To hold that together.
Yeah. No, the tie bar, which is inside the concrete slab, kind of it means that column, otherwise that column would be acting as quite a big long element holding back soil at the bottom, so it helps to keep that column a sensible size. And so this all happened quite quickly, I think, by the time after you sort of decided. I think you already had the timber there. It's like get on with the design, and you
we also had
needed a list, didn't you?
Planning, and we had it all ready
to
go sort of this end.
So I needed to give Tom a list of planks to saw up, and this is a kind of going further into the detail of making these big beams, because I didn't sort of go much into the span. Was it a 90-meter span? 19 or 18?
18, I think.
Yeah, 18-meter span. So they're reasonably big beams. And this is sort of showing how it's stepped and how you work out how much timber you need. That's information we went back to Tom with. I think the next slide will be.
That's Tom starting the sawing.
Yeah, so list of timber presented to Tom, and I'll hand over.
So these are the actual photos of the trees coming out of the woods. So this was a family owned woodland. Unfortunately, the trees were about 40 years old, nearly to commercial sizes, but they got this Phytophthora disease, which has gone through most of the larch in the country, and so you essentially get a letter from the government saying you have to fell these trees in whatever state they are. So ideally this woodland would have been left for another 10-20 years, and probably been slowly thinned out over a period of time, but as it was, it had to just be felled, and got rid of a lot of it. Probably would have gone into the chip industry if it wasn't for us being able to sort of do this building with it. So
sort of rescued it.
Yeah, sort of rescued it. I mean, if you're doing this more commercially, you would be buying slightly bigger trees, which just makes the sawing that much quicker and easier. Being quite small trees, you can only get sort of a few pieces out of each stick. So it was a slower process of sawing than usual, but it was nice to be able to use this timber instead of it just being chipped and burnt. So so if we go on to the next slide, so this basically we've got a horizontal band mill which did all the sawing of this. Simply put a tree on and you'll just slab it down through, and you'll get sort of two wainy edge boards in the center and a couple of thinner ones which then did the cladding for the building off the side. So it really was quite a labor of love sawing all of these trees. The timber, once sawn, is then stacked with little battens in between. With our normal oak and ash flooring that we do, that's then left to air dry undercover, but sort of exposed to the elements for a year to 18 months. With larch, you can dry it a little bit quicker, so it had about 4 months of air drying before it was then brought in into the sheds and kiln dried. So the kilning process on this larch took about three weeks. We could produce basically an Arctic load like this every 3 weeks, and I think it was 5 or 6 lorry loads of timber which had to go through, which was for the glulams, but also for the cladding for the building, for the internals and externals. So back to Robin on that.
Yeah, I think the cladding is quite an important thing, which we were going to talk about more later, aren't you? So the cladding is kind of half the building, isn't it? So Tom did the whole building here, when you include the frame. So this is sort of overhead shot of us making some of these big curved beams.
In a steel shed.
In a steel, yeah. Sorry. One day we'll have a nice shed like you do. But, so you can see the finger jointing line down the left hand side in the factory, and then some sort of people and our kind of people working on the beam. Our sort of setup is not mega high tech, not kind of mega high volume, but it's flexible and it allows us to do these bigger spans and curves and things like that, which are needed for a project like this.
This was getting towards the longest ones at that stage that you manufactured, or?
I think it's some of the longer ones we do, but I mean the longest we've made is 27 meters. Yeah.
How long's the whole?
Yeah, the factory is 60.
Oh, okay.
So it's just we've got the planer right in the middle, so you can actually see on this just beyond the forklift, the thing there is the planer. That's right in the middle of the factory. It gives you an idea of scale.
Yeah.
So we've got about 27 each side, and any bigger than that, it's actually feasible to make, but you have to start opening the door so it can go out the door, or removing some panels in the wall.
And so this is a planer planing the whole beam once.
Yes.
Once manufactured.
Yeah, so that whole 90-meter beam goes through, and that's always a bit of a nerve-wracking something I'm glad I don't have to be directly in charge of, is planing those beams, because it's easy to kind of mess one up, and they're very expensive things to mess up. There's a few more pictures. You can kind of see the manual sort of work involved in making these beams. And actually, what the photos don't show is we would generally make two at a time. So though it seems like kind of a massive job, you stack them on top of each other. So this building's got 7. So it probably took a couple of weeks or less, really. So it's not a kind of, these things don't take kind of really ages to make.
Oh, 8, my bad.
Yeah. Then I've got a little video. Is that going to work? Yes.
Oh, yeah.
Surprise. Yeah, so it gives you an idea of the process.
How long does the glue take to dry?
It's overnight. So it
Oh,
takes
okay.
about,
That's not too.
yeah,
Yeah.
and it's cured at about 30 degrees, so you can see some sort of sheets above it. They come down and help to keep it warm overnight.
Yeah.
Then the next, you can see how it's made as a kind of jaggedy edged beam. Next stage is another video, and this one's a slightly embarrassing one, because actually it's not that bad, but I was thinking when I looked at it before, it's like, oh god, we really we there's too much wastage basically. But you have to consider you need a bit of gap to your glue line, because the very when you're curving something, it tries to straighten out at the ends, so the very ends beyond the point of the clamp are basically kind of not a usable piece of glulam. So that sort of explains why I have to cut a bit off the top. Then back to the panels, which is back to the chief architect.
So as well as the glulam structure of it, we built the rest of it with panels. So these sort of larch dung board on the inside, which again we produced, a timber stud frame, and then larch cladding on the outside with some membranes in, and sheep's wool insulation, because this whole building is heated and kept at room conditions year round, or sort of household room conditions year round. The part of the sort of design spec of this building, one thing that I was sort of quite determined to get was we needed it to be built very quickly, because we couldn't afford to have that much disruption to the business. So you're building it as panels, and then just being able to crane the panels into position was really quite key. So we built most of these panels. We had a couple of the panels built off site, just simply to get the sort of workload through. And then the big day arrived. We had a big crane brought in to site, and well, 4 days basically of swinging in panels and the beams, and we got the whole thing built, and luckily everything fit perfectly, and yeah, it all there's quite a few sleepless nights before that, but it all went together very well. The great thing in a way about this design of glulam is that the main beam is one piece and can just be brought in and then dropped on to the threaded bars which are sticking out the top of the posts. So if you get all the posts in the right positions and held by the panels, then you can very quickly build the sort of roof structure of it. So and even the roof structure itself was done in panels. So each side of the roof was sort of 3 panels per bay, and that's just 15mm cladding, and then the purlings attached to that. The whole thing is sort of swung in together and put down on top, which just meant a really quick sort of build time. The whole building was insulated with sheep's wool insulation. Sort of a huge shout out to Firma Fleece, who the company who manufactured
You
it.
can really see it back here, can't you? That's on top of,
Yeah, these are but the great thing that they did was manufacture the sheep's wool bats to the to exactly the size of the stud work that we were building, and the gaps between the purlings, which meant we had 0 waste on the sheep's wool insulation. It's been so far very impressive, very seems to be very good. We've had some thermal imaging done of the building, and it seems to be working very well. So yeah, that was a really
I think we want, sorry, but we really wanted to build a building that you could be deconstructed with no huge environmental cost, or if in 50 years time or something, if
because our previous building which we had was a steel framed portal building, which was spray foam insulated on the inside, which is a good insulation. But now if that building's ever to be knocked down, you've got a mess of potential environmental disasters, whereas this building really has no,
the whole life cycle has been taken into account.
It can easily be either taken apart, or even if it came to the end of its usable life, there's nothing toxic in it. It's sheep's wool and timber essentially. So we'll be fan of that. And one thing on the sort of design of it, we put the columns on the inside. Larch is pretty durable, but it wouldn't, being that the beams are inside and held up off the ground on short 6-inch stub steels, just means that those frames really should never rot, or not rot for a very long time. Even if the cladding on the outside does degrade in 20-30 years time, we can replace that, but the actual structure of the building should stay well. It does slightly limit space, but actually that can be quite useful for the building it is, which does require an amount of airflow. So having those sort of gaps around the edge is actually quite useful. So yeah, I mean, the shed is basically kept so 21 degrees all year round. The reason for that is once we've kilned our flooring, we can store it in this shed. It doesn't pick up moisture, and it can go straight out to acclimatize it in their houses. So it just means that builders don't have to sort of climb around our flooring for a long time before laying it, so it can come straight from us and straight to site. So that's,
and you can supply people like us. That's the other thing, because actually one of the main and there's a few, it's becoming other sawmills, not that we should sort of say about any other sawmills, best saws, but at the time, the part of the reason we'd slightly given up on locally grown is no one was sort of offering, the 12% is only basically dried a bit more. So we're drying it from like 18, which is sort of standard carcassing, a bit more to 12%. That's what we need to be able to make glulam. So if it's wetter, it will still actually glue together fine. but as soon as you get it inside, it'll start to dry out and cracks appear everywhere. Even at 12%, you're still going to get cracks. But you know, that's the reason for the low moisture content. And a lot of sawmills just didn't want to do that. And the sort of credit to Tom and Polly is that they're actually, you know, just kind of prepared to have a go, and you're used to drying things. You've got the kind of skill set to do that, and that's kind of what meant you could offer the timber. So suddenly we've got a useful 12% KD timber supply down the road, which is what we needed.
Yeah, so yeah, one of the things which we sort of, I suppose, didn't really think of that much in the sort of design and build of it, but has really been noticeable subsequently, is when we sort of show customers around, and you know, people are doing maybe a very expensive house on the outskirts of London, and they do want to come down and just sort of see where the timber and the sort of process, and what is really noticeable, you know, people coming into a building like this, and it's something that it isn't quantifiable. I don't know how many jobs that we've gained because they've seen this building or not, but it's very noticeable how people are, you know, very impressed with it, enjoy being in the space, even though there's no windows in it. Yeah,
maybe it is quantifiable. Yeah, someone clever who's watching might be able to tell us, oh, there's a paper saying, you know.
It is noticeable, and people go up to the beams and stroke them, which is really noticeable.
And also to work in, you can work in here all day in the winter, and it's nice to work in, whereas I'm sure your place is lovely. So
it's horrible.
There's something warm.
Yeah,
nice.
Yeah.
No, this is much more pleasant than
You
our
don't feel
our
like
building.
you're in
Yeah,
and even that one. It's sorry, God.
This is well, yeah, this basically shows exactly where we all are and just how close all the timber was. So yeah, we can't point, but so we are just below, well, we're in South Molton. The timber was close to the top left Barnstable there, the trees, and then we sent it down to near Crediton. So I think we worked it out earlier as 36-mile
sort of round trip.
diameter.
Yeah, we got diameter round trip. It's all in a close circle there. And I think we all really enjoyed that as a project. It was just something that I don't think has been done that much before, and just keeping lorry journeys and everything like that to a minimum, and it helped with cost as well.
And the one thing that was
proved we could,
you know, sort of, I think is worth mentioning is that the timber that was grown on the woodland that we have is, you know, and most timber in the UK is the case, is a lower grade of softwood than what is brought in from you know, Russia or Siberia or areas like that, Scandinavia. So the beams here actually are, they're GL.
It's GL20, yeah. So I mean, it's GL stands for glulam, and 20 is the kind of allowable, or the old characteristic stress. So it's kind of like the maximum stress it can take. And then most imported glulam is C24. So we've just got that sort of slight issue here, and I'm aware that Tabitha knows a lot more about this than me. She'll probably start kind of, but you know, a lot of the timber in Britain is actually faster grown, so it's a bit weaker, or is it perceived to be a bit weaker? But anyway, I think it is actually a bit weaker, slightly, but slightly is the kind of key word. So I think people kind of say, oh, C16 is not, but actually it's still very structurally sound.
And actually it is only you know, sort of 40 to 80 mil smaller that these beams would have been if they were of the higher grade. So, you know, for a building like this and for many applications, it really, you know, it's easily designable in. It makes no real difference, and so we can use English timbers. It just needs a little bit of, you know, instead of just going straight for that GL24, is going for the.
I would even say, like, half the time, if we've got a project where we need to use GL20, say someone's ordered some larch and we don't want to get it from Europe, and it's quicker and easier for us to use local. And we can, because we're engineers as well here at Buckland, so we can go and check the beam size, and I'd say a good proportion of the time you don't even need to change the size. So it's actually, you know, the sizing shouldn't be seen as too big a factor. So if anyone wants to sort of use locally grown glulam, GL20 is the thing to remember.
This is the just another one which we worked. This was a private building, just as a stables for me and Polly, and
Giraffe
Just couldn't
stables.
stop building sheds.
and
Got the bugs then.
a mushroom farm for me, and you know, just a sort of a thing that I'd like to also get across is that we asked Robin on these not to finish the beams to such a higher degree that we would be for, you know, for in a house or something like that. And so for these just, you know, farm buildings, you know, just a plain finish, I think brought the cost down you know, a bit for us, but you don't notice that sort of, you know, so it's sort of picking the right the right job. So this is actually the same size building as the one we're standing in and looking at, and it's just down the road, but it's just another design with straight beams instead of curved beams.
Yeah. Sometimes for us, it's getting out of that mindset of it being someone's house, or so, you know, we've got to kind of like flip between qualities, and it really, that when you come in here, I think it looks better than when it was. I think it's dried out and there's some sort of little black stains and things that have kind of disappeared a bit.
Yes,
but so this wouldn't be okay. But even though it looks kind of really nice as a big shed, it's fine for a big shed, but we might not be fine for someone's extension. We've got to remember that when we're selling someone how much a big shed costs. Yeah. I think that's probably another. I thought even while we're talking here, I'm thinking, because we talked about on Monday about the potential of sort of just selling another one of these, or we should actually really go into because a lot of the time we just sell frames generally, and people are really looking for like the full kind of system. And then Tom's got the full system here, which is, you know, we supplied the frame, but Tom's sort of done the cladding.
Yeah, you could mass produce this quite
so
easily.
I think an exercise for us now is to go away and like really kind of pin down what the building costs, and then all the people watching, if they want one, the same.
Interesting, this building is built also on screw piles and not concrete foundations, because I was fed up with pouring concrete in the ground. So though it's got a concrete work surface, there is no concrete foundations, just screw piled footings.
Okay, now on to that's sort of, I guess that's almost like finished us looking at the shed type of part, and then we were going to go into so part of the kind of story is how what we've gone on to do together as two companies after this shed. And I mentioned it earlier, how we've now got a supplier, and that kind of unlocked the local grown timber for us. So we've probably put some figures to this before. I think we went from one stage, we're probably, this is talking about glulam we make in the factory, we're probably using about sort of 5 or 10% British grown timber at one stage, and now it's more and more. So it's kind of like we're up to, I'm sure we're above 50% now. I haven't got the actual figures, but so most of what we're doing in the factory is local grown, and then we leave the kind of straight standard spruce stuff to the Germans, which they're very good at, and it's a valuable string to our bow, as you could say. So I've got a few slides kind of going through the timbers that we buy from UK Hardwoods. So Larch is probably the most sort of biggest volume one. There's a few Larch projects there. And you also kind of have to think that it's not necessarily like, you're not necessarily sacrificing aesthetic quality to use British, especially for the hardwoods, as I go on to, which is really their thing, UK Hardwoods in the name. But so ash is something, it's really love. I think it's my favourite timber. So we're making a lot of ash glulam, which Tom and Polly are supplying, and you can kind of see in the pictures how, once we've sort of turned it into glulam, it's quite often pretty much knot free, and it's got a really nice colour, I think. And we've got the sort of sad situation that, are all the ash trees going to die? I don't know. Is that the kind of situation? But there are a lot of, you can see if you just look round. I was on the way here, I was just looking, and sort of all the ash trees have like dead sticks at the top. So I don't know if that.
Sort of use it or lose it, because it is going to rot quite quickly. into tree form. So
Would you say most of the timber you saw up has had dieback, or is it just started sort of thing?
no, most of it. I mean, it's not got into the trunks, but they're felling it when the tops have sort of died.
Yeah, so it's a good point to fell it then.
Yeah, it's felling it, but the trunk
It's still alive.
Yes, it's okay. But, it's getting.
It just
getting
makes
bad.
it really brittle if it does go in, doesn't it? It's
Yeah, brittle horrible. Yeah, it gets those sort of brown marks in as well. So just
Yeah, so it does have an effect. That's one thing I was kind of wondering. So I was wondering if brittleness you experience is just because people cutting down trees aren't used to dry wood. And it's actually the strength is still there.
Yeah, I mean, we haven't sawn very many which have actually got the dieback through. So yeah, I don't. Yeah, don't
We don't know the answer. That's a research project for someone. And then oak is another. All the oak we're doing now is British grown. All used to be French, and that's all British. And I think the British. I actually like the French oak tends to look like some of the buildings made from French oak. Kind of to me looks like it could be a plastic veneer, but the British is more got a bit more character.
We have this with the flooring where it's sort of knots can be perceived as or sort of it can be seen as faults, and you must cut them out and get rid of them, and sort of French oak is brilliant because it's or you can with a flooring we sort of look at them as character, and that's actually what makes the floor. I think in the same with the beams, actually some it doesn't affect the strength and small knots, but it actually can make it look sort of a lot nicer, more it's more actually timber instead of, as you say, plastic.
Very much according to taste, isn't it? I do also sometimes appreciate like a big bit of not free Douglas fir or something. So, this goes both ways. And you can also get that in Britain. That's kind of why I keep people come to us and sort of it comes down to the stage where you've got to know where the trees are, and then you can source kind of pretty high end bits of timber if you need to. And well, I mean, have you got anything more? I've sort of gotten to the slide which says thank you. Any questions? But
I think
40 minutes. That's probably
yeah.
Hopefully, if there are any questions, that'd be great.
Is it on us? Can we or?
Yeah. No, that's absolutely brilliant. Thank you all. Sorry, I've got a bit of a noise in the background, but we've got lots of questions in the question answers, and I'll fire them all at you if that's okay. So you've got a mixture of about timber and a bit about engineering. So we're going to start with Will, and he's obviously been really engaged, lots of questions, but I'll just so probably you, Tom and Polly. Out of curiosity, do you know how many stems of larch you actually got? How many cubic meters you used? Basically, they're trying to work out the yield you got from the logs.
I don't know. I have a figure of about 300 cubic meters of larch came into us, but amount of that, some of the logs were just too small and did go for chips. There was some that went for chips of it. The yield, I think, though, was reasonably good because we had, the glulams were sort of 40 mil material, 50 mil material. The dung board was similar. The external cladding was 21 mil. The stud work was 50 mil material, and then the roof cladding was 15 material, which we got out of the sort of falling sizes of the trees. So, and you can actually, if you're here, you can see it, quite narrow boards we had out of those falling sizes. They were, as I say, very small trees. So, I don't know what the recovery rate was, but it was, reasonably good, I think.
Shall I go stop share so you can see? I mean, we could actually. I don't know where the mouse has gone.
It is quite nice to have that alongside, but no, it's we can just stop share completely. Then
Stop share.
There you go. There you got bigger ones of us all. So that you go for a walk around the building now. So obviously with your own building you can actually pick and choose. Obviously, as you said, you use the smaller section size, so that's really quite interesting. On an industry average, it's anything from 50 to about 70% recovery out of a round log, but it depends on what you're doing it. And people say, oh well, what about all the waste? And as you rightly mentioned, you chip, so it's a co-product, not all a structural timber product.
This shed is heated with you know, our waste products then is
Mm.
used in running the kilns for drying timber. So it's you know, it's very much a you know, sort of circular process. So it isn't.
No timber leave this place.
Yeah.
Apart from salt boards.
Yeah.
It's a good business concept, isn't it? Yeah. So on that, there's a couple on adhesive. So Bjorn is asking adhesive type, but let me just scroll down because there's also another one down here, because Will's asking, do you require special types of different types of glues for different species, and these are different curing times?
Yes, but we use MUF, melamine urea formaldehyde, which is sort of industry standard, and we use that for nearly everything. And the only times we go away from that is we've used, so you've got PRF, phenol resorcinol formaldehyde, which is much more sort of toxic but really very durable glue. It's like the original glulam glue. It's been used for decades, but a bit toxic to use. So the only time we go away from that is with a coir we have, and then with some of the sort of really maybe some tropical hardwoods, we might consider it, you know, for it kind of can be used to stick the more difficult to stick timbers, but generally it's MUF for everything.
Thanks, Robin, on that. Just one back for Polly and Tom. How long did it take the larch trees to grow that you used? And obviously I know they were felled sooner than maturity.
I think they were planted in the 1980s, so they would have been around about 40 years old. So, and I mean, it is something that, as a sort of industry, we should be sort of thinking about in a way. You know, these, you know, in a way, these sort of woodlands should be looked as, you know, as a crop. You know, it's you know, with deciduous woodlands, they're very much more, you know, there's a habitat, there's you know, lots of things, but and you know, almost to encourage farmers to be planting you know, their ground to trees, you want to be looking at it as just a long-term crop, which does have a very good long-term, you know, yield and return, but we're just, you know, at the moment sort of struggling in a way to get enough, you know, sort of planted, I would say. But yeah, so large trees are about 40 years old when they were felled. And yeah, normally it'd be running at sort of 50 years before you'd get your first sort of decent crop off.
Yeah, I utterly agree with you. On average 40 to 60 years, but then again, it depends how far north or south you are often.
Yeah,
And yeah, that's it. Right, so Ian is obviously engineer, really interested in the moment-based connection and how this was achieved.
Yeah.
Definitely one for you, Robin.
It's we either do it with a great big plate going up into the timber with a load of dowels, or with resin anchors. In this case, we use resin anchors, which is a good way of doing it. It's a bit less sort of you have to do it in a very controlled way, so you have to sort of make sure you test them and things. But I'd say I wouldn't necessarily advise for engineers to design with resin anchors, because we use, like, I think we sort of slightly factor down the strength, which is based on the sort of testing that we've done on them that you would calculate if you use the sort of iStruct handbook. And so we don't that often use them. So mainly it'd be a big plate going up with a load of bolts or dowels, but in this case resin anchors.
Brilliant. Reminds me a lot of the work, you know, done by Cowley Timber Works sort of early on back in the 80s and 90s, maybe early 2000s. So,
yeah. In this scenario, because they are in some ways more awkward. You've got eight threaded bars, to drop through the steel plate. You've got to get that, really actually, which you luckily they did all work. But what was the?
It's actually, you have that problem, but even kind of more so with a plate and bolts, because you probably would have ended up with like 30 dowels per connection or something like that.
Right. Yeah. So it's just limiting. Okay.
Yeah, resin anchor is actually a really good sort of way of, but it's just got to be done in a controlled manner, you know. Basically to do it with big plates and dowels, there's a lot more machining, and then also there's probably or it's harder to put together. So that's probably the main reason we
Right. Yeah.
being aware that in some ways not, but knowing that we weren't going to put it up, we kind of wanted to make things as easy as we could. Actually. But you were you put it up. You know, I don't think we've ever put a building up as quick as.
Which is great. It's absolutely great to hear. And obviously you're going to be rolling on off the production line now when you've got all your figures sorted out. So a couple of questions now on the actual grading and the lamella. So I'm going to sort of bring them together. So Robin, I think you have visual structural graders on site in Buckland Timber. So Bjorn is asking about the strength of the grade of the lamella compared to actually the finished beams, and then Will's asking a further question, but I'll come on to that.
Yeah, we visually grade, so we just buy in the timber kind of saw falling. It's a sort of so it's kind of cut to that dimension square, and then we'll grade it, which is better than it being graded in the plank form and then us using it, because we can, if a big plank, a 4.8 meter plank, let's say, it's got a massive knot in the middle that means the whole plank fails, we can, part of the finger jointing process, that would get cut out and it would get rejointed, so use much more of the timber. And then the grade question for the glulam is also kind of another positive thing about the use of C16, which is what we can visually grade the larch to, is that when you stick together a load of C16, it's to do with the kind of the probability of a defect being all next to each other is less, because you're sticking lots of bits together, that the strength grade of the glulam you get is higher. And then there's kind of an interesting, I'm sort of answering the second question now, I think. So when you've got C24, you get GL24, so your glulam is then the same grade as the planks that go to make it up. And then if you go a bit higher, you use C30 planks made GL28, and then you start kind of getting into I need to know more about the actual reasons for this, but my understanding is it's to do with you then getting into like the strength of the glue becomes more of a factor. So you bring into, you know, the strength of the finger joint and the glue lines can become more of a factor in the overall strength of the.
It is in a way a lot more efficient.
It is more efficient. Yeah.
Lower grade timber.
Yeah.
Well, there's an advantage for growing.
Yeah, I mean, and also we've got, it's not just in Britain that we grow C16 timber. It's just that we've got used to using, you know, they grow certainly in the Baltics. I'm sure there's a lot of C16 timber grown, so it's good to use it.
Yeah, obviously, I mean, yeah, you can grade to in the Baltics, as you said, easily. They do C16 as well as C24. Probably, what's saying? Any idea what the cost would be compared to a standard steel building?
I'm not so clued up on steel, and the steel prices have kind of, it's almost things have stabilized a bit, but until recently it's like a moving target. Like one week you'd compare it against steel and you'd be in the next week steel's gone more. So
it wasn't crazily different. When the problem is we did this just sort of pricing the steels just before everything went silly with the whole COVID and prices went through the roof. But I seem to remember when we were doing it, there wasn't a vast amount of difference between the timbers, and it's not as though we got. Yes, the timber was slightly, we were buying the trees and not the boards, but actually how it would have worked out a pretty similar price, but I think now steel has gone up a lot more and the zinc plating has gone up a lot more than actually timber. So my guess would be if you built another one, it would be on par
effective. Yeah. I think another thing, a funny thing about, so the glulam, the cost is all, the actual material is quite cheap. So if you want to use a beam in your like house extension, a ridge beam, I mean, we did some sort of looking into this and we found that the glulam, this is even before the steel really rocketed up, the glulam beam is cheaper to do the same job of the steel beam. And then it's when you start adding connections. And then what we do as a company as well, we need to kind of look at is that almost like we're so used to doing bespoke projects we just kind of reinvent the whole thing each time we get a project. We seem to do it in a different way. That's what part of the point of looking at this is a pretty good way of doing it. Let's kind of refine this. The steel portal frames had like decades and decades of refinement. It's kind of just designed down to the last millimeter, you know. It's using the full amount of strength, and you've got haunches things, and so we need to do the same exercise with glulam.
And this is just some of the, you know, if you were buying this shed in a steel frame, there would be no design cost really, because, you know, this is an off-the-shelf item, you know, 18-meter span, you know, they've done hundreds of these, whereas we were having to go through the whole design process, and the cost, you know, is probably 5,000 or 6,000 in just
it would be
the engineering calcs and things.
Calcs of that, which if you're doing them multiple times, all that cost would go.
it would,
You're like, wouldn't it?
Just a quick one from Ian, and I should just tell you, probably, do you have details of photographs? I'm thinking this is going back to the moment connection and the resin and the anchor bolts. Point them at your either LinkedIn or Instagram, and if you've got photographs, then we've got
photos of beams with bits of threaded bar sticking out. And, there you go.
And I think you're quite on LinkedIn, and or Instagram as well, Polly, and there you go. So come and find you on there, and so more photographs on that. Some more tricky ones now. So challenges with insurance, and what about fire? We always end up, you know.
We did actually have the fire people out here, didn't we? It's always been a funny one for us, because although this is a timber shed, we're used to insuring, because even if it was a steel shed, it would be full of timber. So that's always been a bit of a scary one for us.
It was interesting with the so we relatively regularly get the fire service down to have a look, you know, if there was a fire here, what do we need to do, you know, what things, and it was very interesting that he was very positive about this building in comparison to the neighboring building, which is steel with spray foam, and you know, he was very much, well, there is nothing toxic here, so you know, he can, you know, if there was a fire, you know, they could, you know, send people in with relative risk, relative non-risk, whereas the toxic fumes, you know, falling, burning plastic, which would be what would be coming from the other building, you know, he was sort of, we won't go in that, but we won't.
They'll just leave that one.
They'll just leave that one to burn out unless there was people in it. Whereas this one, they were sort of, you know, he was very positive about it and wasn't very worried about it at all. And also, I think there are some good things on fire.
Yeah, so you can. I don't think this building is, because it's not the sort of building you design with fire rating, but you can easily design it to have a fire rating by charring rate. So basically, the glulam burns away at a known rate, and if the bit left inside still works to a different sort of loading set, it's fine. And then I think fire is a very big, so we're always kind of, you know, understandably so, it's a big topic, and so the other thing is, do you fire retardant treat it? And you know, I think that's really got to be done on a kind of risk versus benefit type of thing, isn't it? So you've got a shed full of timber that isn't going to be fire retardant treated. You need to fire retardant treat your shed. It's not really kind of sensible. And if this was a school hall, then you would.
We did actually improve our water source.
That was one of the, but you know, if you were building a skyscraper and things like that, your fire becomes much more of a risk. But with single story or two-story buildings, you know, the fire risk, you know, it's a lot easier to evacuate very quickly, isn't it? So I would have thought there is, you know, this type of building has very little.
No, and it's generally the linings would need a fire retardant if it was another type of building, which is something that can be done fairly easily.
Yeah, exactly. Getting that it's the right application, the right fire treatment for each specific job. But yeah, talk to the specialist. Obviously, talk to yourselves who have you know, knowledge. And when you just said the sports hall, actually, it'd be a fantastic sports hall.
We get involved quite a lot.
And that very, very smooth polished concrete floor that you have is absolutely amazing. But again, you know, people think in the timber industry, we actually don't get involved with all the materials. Oh, look, there she is, your mascot. Again, it's just changing the proportion of materials to make them more, you know, less carbon intensive, more bio-based, and, you know, using the right material in the right place, because you've, apart from glass, as you said, you don't have windows, you've got concrete, you've steel, you've got timber, you've got sheep's wool, you've got a metal roof.
Yeah.
Yeah.
Yeah, this is the thing that's sort of why on the next building we did it with screw piles is, you know, concrete is just amazing for a floor, but you know, as footings, you know, pouring whatever they were, they're about meter by a meter and 2 meters deep, you know, it's just a complete waste of concrete, and you know, it's a lot of carbon in that. I mean, it holds a building up, but you know, whereas you know, on the other one, you know, 2 relatively small screw piles per post, very, very quick, got a lot of advantages. I mean, and it's not anything like the amount of carbon. Just
yeah, it is the only downside of this design actually, is it's got a fairly heavy footing because it's a moment resisting base, which is the way well, steel's a moment all round. But yeah, we look at bracing, you know, I think another way of looking at this is doing some bracing back to end bays, but that's another.
Would the footings be as big if we didn't have that retaining wall?
Yes.
Yeah.
Yeah.
But remember, yeah,
you know, looking at soil conditions, and
yeah, and this is Mark 1, as you said. From Mark 2 you changed it, and yeah, like Mark 3, whoever's up for Mark 3 again, you know, again, it's those incremental improvements, you know, cutting things back and making things fit for purpose. One last question, because we're almost out of time. What is the so Dominica, who I've met, so I know she's on the Timber TED course last time, and Natasha is on our current one. Dominica is saying, what is the project in UK grown oak with a hexagonal roof?
It's like I think it's a sort of kitchen for an office. It's in London. Yeah.
project you've done, Robin.
Yeah.
It's a roof. It's going to have glass in it. Rooftop sort of thing for a back of a house in London. I'm like majorly kind of joint focused, you know. I'm like I sort of
No, that was perfect. I don't feel so bad about forgetting your name now, Robin, when I was introducing you at the beginning. It's like, well, it's that project. It's like, so huge thank you to Tom and Polly and Robin, and obviously you now know where to find them, and if you're down on holiday in Devon, you know, it's definitely recommend popping into both. And if you're a university and want to do research, so much research there, you know, and I'm sure you're all happy to, you know, work with our future professionals and any research people who are interested in research. Our last of our series is the Fenland Black Oak. Absolutely, again, another amazing project, which will be on the 12th of July. And just to reiterate, 9 days left to enter this year's Wood Awards. And so we look forward to receiving lots of fantastic entries. And you never know, we might be talking to you next year. So just with that, I'd like to say a huge thank you.
Thank you.
Cheers. Bye-bye.